Hello and welcome back to the Networking Fundamentals section of this course. In this video, we'll be discussing longest match routing and layer 3 routing decisions. See, the first thing that a IP router looks at when a packet comes in to be routed is it looks at the destination and then also looks at its routing table and chooses a routing entry according to what it has for that destination. And the very first thing that is the most important is it will select the longest match. Now, longest match refers to the prefix length. The longest prefix with the longest match is what it will use to forward the traffic. So let's do a quick review of prefix length. The length of a subnet mask is called the prefix length. This is because the network portion of the address is called the prefix. So in a 26-bit network mask or a /26, we have 26 ones, which means we have a network portion of the address that is 26 bits long. Or you could say the prefix is 26 bits long. Similarly, with a 21-bit subnet mask, we have 21 bits in our prefix. The longer the prefix, the fewer host bits in the address. Where I have 26 bits in my prefix, I only have 6 host bits. Where if I have 21 bits in my prefix, then I have 11 host bits available here. So the fewer the host bits, the more specific the route, meaning there are only 6 bits over here worth of hosts. That is a more specific. There are fewer hosts in that pool than in this 11 bits here. Okay, so now that we have a sense of what our prefix length is and what it means to have a more specific route, let's take a look at what our routing table contains. So our routing table contains a prefix, the protocol that routing entry was learned from, the next hop, including the interface for that routing entry, and then also the age of that routing entry. On the right here, we have an example of a routing table shown on a Juniper device. These are IP version 4 routes. Let's take a look at our second entry here. We have 10.1.1.0/30. This is our prefix. It is learned by the direct protocol. That means that we have an interface that has an address in that subnet. The next hop is this interface here, GE000.0, and the age of that route is 1 day, 3 hours and 25 minutes and 38 seconds. Now the route directly above it, this static route here, 1.1.1.2/32, was learned by the static protocol. It is a statically assigned route. The next hop is 10.2.1.1, and it is via the GE001.0 interface. We'll talk about interface naming convention and the different protocols that you can learn routing information from later in the course. But right now, I wanted to review what the contents of the routing table looked like. So let's take a look at the next slide here where we give an example of longest match routing. Is that if multiple entries in the routing table include the destination IP address, the longest match is used. let's say we have a different routing table down here. We have 3 routes, a 0.0.0/0, the 192.168.2.0/24, and 192.168.2.212/32. The 0.0.0 route is the default route. This matches everything, all destinations. The 192.168.2.0/24 is more specific. It has a 24-bit length prefix, whereas the 0.0 route has a 0-bit length prefix. And then our most specific here is the /32 that has a 32-bit length prefix. So if we have a IP destination for our packet of 192.168.2.4, it will use the /24 entry here, even though that destination is matched in our 0.0 route, that this includes everything. This is a catch-all. Even though that does include our most specific route that includes this destination is the /24. Now, if we had a destination IP address of 172.16.04, then our 0.0 route would be used, because neither of the other routes include this destination. Only the 0.0 route, which includes everything, is used. It is the least specific route that exists. However, it does include everything, which is why it's called a catch-all. To touch on just a few of the other indicators here on the routing table, the access internal, this is from being DHCP. This particular lab device is a DHCP client and learned its default gateway from DHCP. And then it is directly connected to the 192.168.2.0 network, and the interface IP address is 192.168.2.212. Hence, it is a /32, which is one individual address. There are no other addresses in that network. Excellent. I appreciate you going through the longest match routing with me. I hope that this has been informative for you, and I'd like to thank you for viewing.